Hi, thanks a lot for watching this video, and thanks to PerfGuild for having us in this online conference. My name is Stéphane Landel, and I'm going to talk you in this video about the load test tool that I created, which is named Frontline. So in this video, I'll be talking about show you a bit. Tell you a bit about the history of Gatling, how it became an Poste project and what we've built so far, and tell you a bit more also about how Gatling is quite opinionated about the way to build load tests. I will talk also about how Gatling is quite efficient and can let you generate quite a huge load, and we'll tell you also about the opinion that we have regarding reporting and regarding the kind of metrics that Gatling provides. So first, focus on Gatling open source. So Gatling is an open source project I started 6 years ago. It's published under Apache 2 license, and you can find the code on GitHub in the Gatling organization. The open source work has been very steady since the beginning, so you can see that it's really an active project. We release several times a year with new features and bug fixes, etc. We plan to release the next major version, Gatling 3, either end of this year or beginning of next year. So our company, Gatling Corp, provides, does most of the hard work on the open source version, and then we also provide professional services like training, mentoring, and we also provide this kind of enterprise version of Gatling, which is named Frontline, that provides you with many more features that you don't have in the open source version, like distributed tests, archiving, on-demand deployments, and way more metrics than what you have in your open source version. Gatling is quite popular, actually. It's quite great that, when we released the first version, I think we had something like 20 downloads, and now the project is very popular thanks to our community. For example, last year, there were something like more than 20 conferences in 10 different countries all over the world, in Europe, US, even Japan, talking about Gatling. So really huge kudos to our community members who spread the knowledge. The project is quite popular on GitHub. You can check it there. Also, if you need more information about what we release, I encourage you to follow the Gatling tool Twitter account, and also join the community mailing list. And if you feel like a Gatling expert, really feel free to help other community members with their questions on our mailing list. As I said, it's quite a popular project now. It's been downloaded 700,000 times since the beginning of the project. And really the downloads are really skyrocketing those last years. It's being really used all over the world. We are based in France, but the project is being used a lot in the US, in the UK, and all over Europe, and also in the rest of the world. I'd like to focus about the opinion that Gatling has on how to craft the load test. The thing is, if you consider what tests are about, tests are really about providing quick feedback on potential issues, so that the team members, the developers, or the ops people can quickly fix before it's too late, before the impact to fix is too large and too expensive to fix, or that it would jeopardize the go live. This kind of We've been able to achieve this kind of quick feedback with functional tests for quite a long time. So with functional tests, we can have maintain tests with the test being pushed on a source control system such as Git. We can do peer reviews, so our team members can control and give feedback on the test. We can build dry tests, reusable components. We can also build libraries for our tests. We can also we can also run our tests periodically, several times a day, plug them onto our continuous integration. And really what's interesting with functional tests is it's not just the sole task for a QA team. Really all the team members and all the developers are really involved into the tests. Question is, how could we achieve that with a functional test? We could do that because functional tests are nowadays mostly text, not something that you craft with a graphical user interface. Just have a look at things like JUnit or Selenium or Cucumber, etc. You really have text with an expressive language and not graphical user interface. So really the question was, why cannot we achieve that for load testing too? Just another kind of test in the end. So what we really need is things like DSL and or actual programming language, actual code. This piece of code is an excerpt of a Gatling test, and I think even if it's the first time that you see this kind of the first time you see Gatling, you can pretty quickly understand what this test is about. It's a scenario named basic simulation that would hit the home page and then perform one 5-second pause. So really, in the opinion of Gatling, the load tests are just another kind of test, and you should be dealing with them the way you deal with the other kind of tests, not with a graphical user interface, but actually with code. The next point I would like to focus on is about performance. Quite often I experience performance issues with the load test tool where the poor performance I was experiencing was actually coming from the load test and not from the system of the test. What Gatling has, on contrary to other tools, Gatling has a kind of different threading model. If you consider other tools, you can say that virtual users are implemented as dedicated threads. The thing is that when you just run a few threads or a few dozens of them, your load test will execute smoothly. The thing is that when you start trying to generate thousands or tens of thousands or hundreds of thousands virtual users and you implement them as thread, your load test will start experiencing some troubles. That's not how you should be using threads. The thing now also with some other tools is that some of them use blocking IOs. So those threads are quite expensive resources, and at some point you realize that they spend a lot of time just blocking, waiting for responses. It's just like you've sent a letter and you're waiting in front of your mailbox, waiting for the response of the other person. It's just a waste of resources. Another waste also is the think time. How do you implement think time when your when your virtual users are just threads? Well, you use the sleep method, and once again, it's just a waste of resources. So when we designed the Gatling architecture, we wanted to come up with a modern architecture and a proper sane usage of threads. So what we have with Gatling is a message-oriented architecture. All the orchestrations of the virtual users are done with ACA, which is an actor framework running on the JVM. And what we use for IOs is the Netty framework, which is the top IO framework on the JVM. And if you check the Gatling documentation, you won't see any mention about threads. With Gatling, virtual users are not threads, they are just messages that are being processed along a workflow. And of course, we use threads underneath, but we just use them as technical resources to process the virtual users. So typically on an 8-core machine, Gatling would run with something like 40 threads. With this kind of architecture, you can achieve pretty good throughput. On this example, so we are hitting a REST API. So we had 2 different machines, one for the Gatling injector and one for the REST API that was returning one JSON-K payload. And you could see that we could achieve more than 100,000 requests per second with 1,000, I think, with 1,000 virtual users. So you can achieve a pretty huge load with Gatling. Next point, specific that Gatling tries to emphasize is the metrics that we report. If you really care about your response times, you should pick a proper metric. What I mean is that there are quite a few tools that just give you one single, let's say, chart and line over time with one single metric called response time. And this is actually the average value. The thing is that really the average value is a poor metric. Well, if you have a poor average response time, yes, you have poor response times. But you could perfectly have a good average value and actually miss the fact that 20% of your virtual users are experiencing poor response time. You wouldn't see that with the average value. Some of the tools also provide you with, along with the average value, the standard deviation that's supposed to represent the way that values are close or not from the average value. The thing is that actually this metric is only significant for normal distribution, so perfect curves and symmetric curves, which is something that you never have on real world systems. So what you really need to know about your system is the response time distribution. How am I faring for 90% of my users, and how bad am I for those 10% remaining? So with Gatling, what we provide is a series of percentiles that give you really proper insight on your distribution. Really, you shouldn't be assuming anything about your distribution. You should be measuring them. Okay. Also, if you have a load test tool that provides you with percentiles, so you should make sure how they are being actually computed. Typically, beware of systems that provide you with averages of percentiles, because, for example, they are measuring percentiles every second, and when they try to aggregate those percentiles every second to, for example, provide you with the overall value or the overall value on a whole cluster of injectors, or just because you're trying to display a chart that can, let's say, display 100 plots, but you have 10,000 records in the database. So you would have to reduce those many records into a smaller number of plots. How can you do that? The only way would be to compute an average value of those percentiles, and this is just completely wrong maths. Typical example, the 100th percentile is maximum, and are you really okay with a tool that would provide you an average of the maximum? This doesn't really make sense, and when you have this kind of tool, you end up with kind of smooth curves with, let's say, reassuring results. And when you start zooming in and getting closer to the resolution that you have in the database, you'll end up with start seeing all your hiccups and realizing that, oh my God, no, my distribution is way worse than what I first thought. Pick a tool that provides you with proper metrics and properly computed distributions. As Gatling is really code-oriented, it really integrates well with developer tools. So with Gatling, what you use is actually the Scala language. So it runs on JVM. And so it typically integrates very well with the Java and JVM ecosystem, like the IDEs such as IntelliJ or Eclipse, different build tools such as Maven or Gradle or SBT. And as those are in the end, as your test will just be source code, you can push them, store them into your source control system like Git. And also it integrates pretty well with a continuous integration pipeline. Typically, we provide Jenkins plugin for the open source version, and we also provide plugins for Bamboo and TeamCity for frontline or enterprise version. One interesting thing is when you plug Gatling in the continuous integration pipeline, it's very interesting because first you can make sure that even if you just run smoke test, you can make sure that your load tests are always up to date when you'll try to run them at full scale. You can also run them on a smaller scale system where actually you would have kind of baseline of your stats, and maybe be able to pick to figure out some performance regressions from one build to another. And Gatling will let you define acceptance criteria on your test. Criteria such as I want my the response time maximum. I want the 95th percentile of my overall response times to be below a given threshold. Or I want my error ratio to be below a given threshold. Otherwise, I want to fail my build, report that into Jenkins, and maybe send some notifications from Jenkins. So yeah, as you see, the Gatling ecosystem is quite rich, and it provides quite a few features that we think fit quite well in the new DevOps movement. So now with the demo. So you can use Gatling in many ways. The most simple one is to download the zip bundle from our website, and you'll just incompress it. You'll have all the Gatling libraries that you need. You just need a JDK and a text editor, maybe with syntactic coloration for Scala. And what I'm going to show you here is how you can integrate Gatling with your IDE and with your build tool. So here you can use, for example, Eclipse or IntelliJ. You can use Maven, you can use SBT, you can use Gradle. What I'm going to show you here today is Eclipse with Maven, but it will work just the same way with the other tools. So here you have a Maven project that you can see that it's the standard Maven structure, except that it has Scala directories instead of just Java ones. You can find samples of this kind of projects on GitHub in the Gatling organization if you want to have some samples to bootstrap from. Then here you can see that there's those two classes that are very similar to the launch scripts that you have in the zip bundle. So here you have a class to launch the recorder and one to launch the load test engine. Let's have a look at the recorder. So you can use the recorder in two ways. The first one is to use it as an HTTP proxy that you will configure on your browser, and then it will capture your HTTP traffic and generate a simulation from that. Another way is to use it as an HTTP archive file converter. So you can grab those HR files from, let's say, Chrome Developer Tools or Firefox also. It's a kind of JSON file that describes your the way you've browsed your different pages and HTTP requests, and you can use the recorder to convert that into a Gatling simulation. Here I'm going to show you the HTTP proxy mode. So let's have a look at the configuration. I'm going to use self-signed certificate. So I have here the listening port of the HTTP proxy that I'll have to configure on my web browser, the name of the package and the name of the class of the simulation that I will be generating, and a list of resources that I don't want in my test, typically static resources. So let's start the recorder. For this demo, I'm going to use this application, which is just a list of computers that I can search, browse, and also add some new computers. So let's create some tags. So tags are just comments that will be generated in the simulation, so I can easily figure out which my requests were. So the first process I'm going to capture is a search process. So I'm going to the home page and I'm going to search for MacBook and select the MacBook Pro. Then I'm going to have a browse process. Back to the home page, and I'm just navigating from one result page to another in the list. And the last process will be an edit one. I'm going to add a new computer, fill the form, and just paste it. And then stop, shut down the recorder, and if I go back to my IDE, I now have a simulation that's been generated for me. Here it is. So this is how a typical Gatling simulation would look like. So it's a Scala class. You can see here the name of the package, some imports that are required to have the Gatling DSL work properly, and then the name of my class that has to extend simulation. Then I have a configuration for the HTTP protocol with some common configuration for all the requests. So here is the base URL that would act as a prefix for all the relative URLs in my test. So I can use that to easily switch from one target environment to another, from development to test, QA, to pre-prod, etc. I would also configure here a list of common headers for all the HTTP requests, so I don't have to copy-paste them all over the place. And then I have my actual scenario. So a scenario, as you can see, is typically a sequence of HTTP requests. So here are gets and poses, think times, that are in seconds here. And you can see that the values in here are the ones that I actually experienced when browsing my application. So I can see also my different tags, so I can tell apart my different processes. And finally, a most important thing is the setup. So the setup is where you tell which scenarios you actually exactly want to use in this test, and how many virtual users you want to inject in those different scenarios, and then also attach the configuration for the HTTP protocol. So what I'm going to show you here is how you can reorganize things, keep things dry, and also build reusable components that you can recompose the way you want to build higher level behaviors. So I'm going to extract the different pieces of my processes into kind of libraries. Here I'm just going to use what's called in Scala objects that are singletons that I can typically use to store constants. I'm going to create them in the same file, but in a real-world project, you will probably have them in their own file, maybe in different namespaces, different packages, or even in a different library that you would share across your organization. So I'm going to create an object for search, an object for browse. I'm just moving things around here. Yeah, and finally, edit. Done. So you can see that now I have an empty scenario. So I'm going to reattach the different process pieces into a global sequence. So the first one was search. So I can use, you can know that I can use auto-completion from my IDE. Then it was browse. Sorry. And edit. And what's interesting here is that now that I have those small process pieces, I can recombine them all together the way I want. For example, I can describe two different scenarios. One would be administrators, and the second one would be regular users. And I can say that only the administrators would be able to do addition. And then I can have those two different populations of virtual users with different behaviors run concurrently in the same test, and maybe with different injection profiles. So I could say, for example, I can have 10 administrators and 1,000 regular users. So really you can now build libraries of processes and reuse them the way you want. Small information about the injection profile. So here I'm injecting virtual users all at once. But I can really draw the injection profile the way I want. For example, I could say I want my virtual users to ramp them over 10 seconds, let's say. Here I am. Oops, sorry, missing parent. Let's clean up now the different processes. So the first thing is that I'm going to give meaningful names to my request, so they can display nicely my reports. So this was the search, and this was selecting given results. I'm going to change the post time to 1 second for the sake of the demo. So if I'm injecting that many virtual users in these processes, you'll see that all the virtual users will play the same URLs and use the same records in the database over and over again. So my test might not be very significant. I might actually be testing my caches, not my system under test. So I want to parameterize that. One way to do that is to inject some data in my virtual users so that they would behave differently and use different records in the database. One typical way to do that is to use our what we call feeders. So I'm adding an extra step in my scenario workflow, which is try to pick a record from a CSV file. Let's have a look at this file. So it's really plain old CSV file with the first name contains the name of the columns, and then you would have the values with the different records. Every time a virtual user will reach the feed step in my scenario, it will grab new pairs of key values where the keys would be search criterion and search computer name. And I can then use this data to parameterize my request. So here we'd say, and the syntax for Gatling is to use this to define some placeholders to be replaced with data coming from the virtual user memory space, what we call session. So now this request is parameterized. I might want to do the same thing for the second request, but this is an ID. Maybe it's not that. It doesn't really make sense to have that in a feeder. What I would actually want is to capture the name of the link, the link that was named a MacBook Pro in the response of the previous request. What I'm going to use for that is a check. So going to use, as I'm parsing HTML content, the one convenient way is to use CSS selectors. Sorry, just pasting. So here I'm going to grab in my HTML content an A tag, so link, whose text contains MacBook Pro. And actually what I want is the content of the href attribute. And save that in the virtual user session under a new key, name URL. And then I can use this new attribute and as a placeholder to replace the URL of the name, the next request. Actually, I don't want to I don't want to always try to capture MacBook Pro. I want to capture the matching result from my search. So this is the second column of my feeder. I can replace just with the usual way, the usual syntax. Now, second process, the browse. So you can see that this is basically a sequence of requesting page 0, then page 1, then page 2, then page 3. So this is actually a loop where I want to have an incremental counter to change the index of the page. So in order to have this kind of loop, for example, you can use in Gatling the repeat component. Let's say repeating twice a given sequence. So if I just do that, I'll be hitting page 1 over and over again 5 times, which is not what I want. So what I want is hit page 0, and then page 1, then page 3, 2, etc. So I need a counter, and actually the repeat component can provide me with this counter. I just need to force the name of the counter that's been used internally. So able coding it Y, and this counter is actually stored in a virtual user session. So I can use it just like any other session attribute with the same kind of placeholders. I'm done. Then the last process. So this is the form, and this is the post. So here, with all my many virtual users, I'm going to actually update the same computer over and over again, which is in the real world not I would want to do. I would probably want some kind of feeder or find a way to generate some random data directly in memory during the test. But I've shown you how we can use feeder with Gatlings. So what I want to show you now is how you can perform some retry on failing requests, and how you can also build programmatic components and programmatic behavior. So with Gatling, we have this component named trymax that lets you wrap a sequence that you want to absolutely succeed. And if it fails, you want to try it over again. This is, for example, useful. For example, if you have an application that requires the users to be authenticated and sometimes the login fails, you don't want the virtual users to keep on processing the rest of the scenario because they wouldn't be authenticated. And also, you might actually want to have them try logging in several times before finally giving up. So you can achieve this kind of behavior with trymax. Let's try to make the second request forcefully fail. So I'm going to add a check here on the HTTP status, and I'm going to say, okay, I want to make sure that it's, so if it's 200, this will should be succeeding because the check will be applied on the landing page after the redirect after the post. If I change that to 201, this request should always fail and I should trigger the try max behavior. What I'd like to do is find a way to have this fail once over twice. How can I do that? Let's say, so I'm going to compare to random number. Let's say, so 200, and I'm going to use a thread local random from Java. So this should return either 0 or 1. So this should be compared against 200 or 201, and this should fail once over twice. If I try to run that, well, it's a kind of classic Gatling pitfall. You'll see that this would fail once over twice. Why is that so? It's because this is actually only evaluated once when the simulation is actually loaded and built. Not every time virtual users try to execute the request from this component. So what we want to pass to the is method is not a value. What we want to pass is actually a piece of code that will be executed over and over again, that is called a function. The standard signature for the function that can be passed to the Gatling DSL components is this one. The input is the virtual user memory space of the session, because you might want to fetch some data from this session to generate the data that you want to return. And when I run that, you'll see that I'll be actually, this piece of code will be executed, evaluated over and over again. So let's try to run that. So now I'm going to run the engine. You'll see that I have some information in a yeah, I thought one thing. So I want to change the behavior of my feeder because the default behavior would be a queue. So at some time it will be empty because I have more virtual users than I have entries in my feeder file. So I'm going to use a different strategy here, say random. And I will pick a random entry in the file. So let's run the recorder. Let's run the engine. And you can see that I have some information on the progress of my test in the console. And then I can see that here I have my first request failing because of the random failure that I've triggered. At the end of the test, I have some recap of all the stats and also a link to the HTML reports that Gatling has generated for me. Let's have a look at those reports. So I have this global page that gives me an overview of all the stats of the different request types. So I have the list of all the request types in my test with different stats, so I can easily figure out which one was the one with the worst error ratio, which one was the one with the worst response time, and some global stats, so the number of virtual users in my test, the global response time distribution, the global response time distribution over time. And I can directly also jump to a given request type to get the stats for just this particular request type. So the arrows, you can see that I have my random failures and my response time distribution and response time distribution over time. That's it for Gatling open source. Thanks for watching. And now if you have some questions, well, feel free to ask. Thank you.